In section 7.3, we're going to learn about a new theorem called Cpctc. That's an acronym for something, and we'll talk about that in this video. So once we can prove that two triangles are congruent, so remember so far we've learned those four theorems like angle, side, side, angle, side, and side, angle, side. Those are the four that we've learned so far. If I can prove that two triangles are congruent using any of those theorems, let's say that for these two we prove them congruent by angle, side. I can then assume that every other corresponding angle and side is congruent. So remember, that's the definition of congruence. Every angle matches up, every side matches up. So without really having any information told to me about the other angles and sides, if I know these triangles are congruent, then I can assume that these other two sides and that third angle is congruent as well. And that is really what Cpctc is, which stands for corresponding parts of congruent triangles are congruent. So basically what that's going to look like in a proof is that after we prove two triangles congruent, we can then, in like the next line, prove that any other part of that triangle that we hadn't talked about yet is congruent, or between those two triangles are congruent. So let's look at one proof, and that'll be it for this video. Let's say we have this diagram here. We're given that angle KBC is congruent to angle ACB. We're also given that angle K is congruent to angle A. And we want to prove that KB is congruent to AC. Notice here, this proof isn't stopping at proving that two triangles are congruent. We want to prove that two segments are congruent. So our game plan here is we're going to prove that the triangles are congruent, and then we'll use Cpctc in the end. So let's go through this proof as normal. So let's start with our givens. So we started with our givens. So I have two angles congruent. I really just need one more piece here to prove that the triangles are congruent. I see that they share side length BC, so I'm going to say BC is congruent to itself by the reflexive property. And now I have enough to say that triangle KBC is congruent to triangle ACB by the angle side theorem. So now I have those two triangles that match up, and I want to prove that KB is congruent to AC. So I'm looking at those triangles, and I see that KB and AC are two sides that are like corresponding in those two triangles. So since I know that the triangles are congruent, I know that these sides would match up. So my reason here for saying that KB is congruent to AC is Cpctc, or corresponding parts of congruent triangles are congruent.